Allora, devo dire che io sostituisco Maurizio Benfatto perché non è potuto partecipare a questa conferenza e siccome oh yes I'm confused, because Maurizio I just organized a meeting in Prato about spirituality and science, and the rule there was to speak Italian. That's why I forgot that here there is not that rule. And so I believe that the subject of biophotons is very important, and I want to present a kind of introduction because there also April will be talking about biophotons, and also Ayuni, I think, will be talking about biophotons, and therefore I decided to replace Maurizio. And so the title of this talk is high-dimensional neuropsychology, which is a very strange, seem to be a very strange connection, but I will do my best to explain that there is a connection. I will define high-dimensional neuropsychology later. So here I limit myself to notice that according to our analysis of complexity, temporal complexity, there is a surprising connection between the dynamics of between the temporal complexity corresponding to the emission of photons, biophotons. So Maurizio Benfatto made a very interesting experiment. He studied the biophoton emissions of lentils, and he found a result that, in my opinion, is very surprising, that the temporal complexity of the biophotons emitted is essentially identical to the complexity, the temporal complexity of the brain, the electroencephalogram, or the heartbeats. There is a surprising connection. And so to explain that connection, I have to introduce to you to the concept of crucial events, which is Bruce West yesterday already discussed the crucial events. And here there is a kind of summary. So what the crucial events are can be derived from using the argument of Kolmogorov about turbulence, or might have another derivation that was proposed by Cox, which is explicitly connected to what they call renewal processes. So there is, let us say, imagine that you fly from Pisa to Dallas, and you see that from time to time there is turbulence. And so Kolmogorov gave a theory that is very important, and so there is the time distance between two turbulent events is given by a waiting time distribution that is defined here is psi of tau, which is what is important, that for tau tending to infinity it goes as 1 of to tau to mu. And mu can be between 2 and 3. And in this case, the scaling produced by the process is given by delta equal to 1 over mu minus 1. So this condition is considered to be stationary, but is not correct. And it is frequently mistaken for FBM. It is possible to, there are many experiments, neurophysiological experiments that have been done using FBM as a theory, but there is a big confusion because, well, I don't have the time to talk about that, but I believe, I hope that this work might help to lead to a distinction between FBM, which is a process without crucial events. FBM is a process where you have a stationary correlation function. The correlation function characterized by the sequence of turbulent events is not stationary. It might become stationary for time distances, large time distances, and is confused with FBM. And there is then the condition move more than 2, which cannot be confused with Brownian motion, is not stationary. So there are aging effects. Those aging effects are perennial. And so I would like to start illustrating to you a paper. It was done in 2021. So you have analyzed the data that Herbert Jelinek gave to us about that bit of patients under the influence of autonomic neuropathy of increasing intensity. And what we found is that at the very beginning of the disease, it is impossible to distinguish that bit of the patient from those of healthy people. But as you go ahead in time, and when you are very close to the death, because it is a very bad disease, the scaling remains more or less the same, but the crucial events disappear. There are no more crucial events. Now, if you study you apply the same analysis to the biophotons emitted by germinating seeds, you find that there is a transition from a condition similar to that of an healthy brain to the condition equivalent to the brain, the art. I was talking about art, but by the way, today there's been a discussion about the connection between art and the brain, and probably, I don't know, today or tomorrow, Kurush will show to us a way that corresponds to a surprising, a synchronization between brain and art, called complexity synchronization. So what happens is that if you adopt this interpretation, you are led to imagine that the transition from a condition similar to that of a healthy brain to the FBM at the end, it corresponds to the fact that the emission of biophotons occurs in an environment that is not the proper environment for the seeds. And I would like to mention some possibilities that are emerging from the properties of the biophotons. First of all, in Boston, there is a medical doctor, his name is Paolo Cassano, who is using biophotons as a non-invasive stimulus for the brain. The brain of people with mental diseases. And there are the literature on biophotons is expanding. There are many new papers, and it seems that the biophotons might be also considered, might establish a connection between neurons. And not only that, but it seems that the biophotons might have also this is in this paper by Cecile Moro, the role of repairing damages. So if there are errors in the brain, they can repair the error. And also this other paper that photophysical mechanism of photobiomodulation therapy as precision medicine seem to be emphasized the role of therapeutic role of biophotons, which is, by the way, one of the reasons why I didn't want to cancel the speech of Maurizio Benfatto, because in my opinion, biophotons are very important. And okay, I would like to keep my my talk as short as possible to give room to April. So there is another important problem that you should discuss is what you call complexity matching, which will be discussed by Kouros. Therefore, so the idea is the fact that the presence of those crucial events in one system, the system A, and if system A exerts an influence on the system B, if the two systems have the same complexity, there is a transmission of information. Okay, this is that's something that you discovered many years ago when they called complexity matching. I would like to mention very quickly some issues that are connected with the study of biophotons. Well, the germinating seed. So germinating seeds are system growing, right? I'm not a biologist, therefore, so they grow, and usually to study the growth of system, people adopt the logistic equation, but which has been mentioned here in this conference many times. But the logistic equation was studied by May, a biologist, and it was considered to be extremely important to explain the existence of chaos. But when you integrate this equation, you have to be, so usually what you have to do, you have to imagine that the integration time step is 1, and alpha and beta are of the same. So if you want to convert that into the May logistic equation, you cannot study the case where alpha here is 0.1, beta is 0.01, and delta t is equal to 1. You have to establish a connection between delta T and alpha and beta. And one of the ideas that many years ago, or probably, well, I remember that there was a discovery done by a gentleman, his name is Ross Kennedy, that decided to combine, to perturb the logistic equation with a stochastic process so as to establish a connection between chaos and stochastic fluctuations. And one possibility is can be done here. So you can. So it's described here. There are two equations that are expected to. You see the master equation that you forget about the logistic equation. Here you have a proposal for the creation of an anomalous process. There are two proposals, and they are expected to generate Levy processes, and studying the interaction, superposition of the two processes, it is possible to realize what Kennedy had in mind many years ago. And so in the sense that the crucial event, even if alpha is a number much more than 1 and beta much more than 1 and delta T is 1, but you can establish a connection between the crucial event occurring at a larger time might establish a connection with the chaos. Then there is also another possibility that is mentioned in this paper, that it was done 2 or 3 years ago. So it is essentially the study of the logistic equation using the corresponding Fokker-Planck equation and replacing the ordinary derivative with the fractional derivative, which is a possibility of. Then here I would like to mention a proposal done by Bruce West in a paper that he wrote in 2022, which is essentially, but there is the problem that what was done by Garland was to establish the fractional derivative at the level of the probability evolution. Well, the proposal of Bruce would correspond to introduce the fractional derivative at the level of trajectories. This is the problem. There is a problem that all the trajectory and densities are equivalent, or it is possible to get two different kind of. This seems to be a stupid question, but Mr. Grigolini and his student Tomio Petrovsky wrote papers claiming that they are not equivalent. So this is. So what I'm trying to say is that the study of biophotons is not trivial. So there are. Well, by the way, I realized that there is a lady here that probably tomorrow will make a seminar about cancer. I was very impressed by what she wrote because she wrote many papers in English, but I don't know if the lady is here. Anyway, I know that she's supposed to have a discussion about cancer, and she mentioned the idea of the cancer. She used the idea for an orchestra. So that you? Oh, okay, very well. I'm very nice to meet you. I was impressed by that statement because you have been using that concept in the past, and but of course, cancer is the enemy. So the fact that the enemy is intelligent is very bad. So you have to, well, I like very much the idea of the orchestra, but you have to see what it can do to destroy the if the cancer is intelligent, what it can do. Well, I don't want to spend time on that because probably my time is over. Right? How much time I have? 3 minutes. Okay, done. Let me finish. I would like to mention that this is a work done by, this figure was done by Maurizio Benfatto, and has to do with the use of the logistic equation to study is biophoton emission. Of course, take into account that here the red line that you see is not is the mean value of at any time there are many many photons emitted. They are distributed. There is a fluctuation strong, and in fact, the theory that I've been using to make the claim that they are equivalent to the brain is because you studied the fluctuations. And I believe that, okay, just a few minutes to say, there is, I have to say something about high-dimensional neurophysiology. This is a paper written by Thomas Parsons, who is as the fantastic, well, he's a very good psychologist, but he's also a very good in looking for money. And I think that he got something like $50 million for his research work, and recently for something that is connected to multidimensional, high-dimensional neurophysiology, he got more than $5 million, which is for 3 years, I think. And I believe that you see, if you read what his paper, and you see that there is a deep connection with, well, there is also a connection with the issue of artificial intelligence, but I know artificial intelligence is the neuron networks are characterized by a property of being stationary. You know, here, stationarity is over. You cannot use stationarity. And therefore, we believe that we can contribute to the success of the work of Thomas Parsons, improving artificial intelligence. Yes, using the non-stationary property that you found. I believe that that's all. I think that, thank you very much for